Hi, myself Gopal Krishna GP. I will be explaining the project Steganography, which I have done as a part of C module. So, what is steganography? Steganography is the practice of hiding private or sensitive information within something that appears to be nothing out of the issue. So, basically, we are concealing a file. It can be an image file, message, or video or audio in a message file, image, or video. So, basically, what we are doing is that we are concealing a message or any formatted file, and we are hiding it in some format. Like, it is a practice of concealing a file within another file. That file can be image, message, video, or audio, and it is done to hide sensitive information like credentials, data forgery, message passing, and all. So the purpose of steganography, it is used in military intelligence agencies, online elections, internet banking, medical imaging, and so on. So how is it done? Here we are using digital steganography. So digital steganography means hiding the message inside lower bits of image or sound files. Basically, we are modifying the LSB of a file. For an image file, it consists of its own format and pixels and all. So we are modifying the LSB. So image steganography, here we are doing image steganography. So it means that making use of image to have the hidden data. The secret data is hidden in an image which will form a new image which will look exactly like the old image. So here in this project, what we are doing is that we are taking an image and we are passing the secret message along with the image, and we are modifying the LSB bits of this image, that pixel data. We are modifying the pixel data of the image and we are encoding the message inside that image, and we are recreating another duplicate image which consists of the data. The original image encoded with the secret data will form a new image. Here we are calling it as steganography image or stego image. So since the modification is done in the LSB side, only a minor changes in its resolution will happen. So LSB image steganography, coming from that part, we are doing digital steganography, and we are doing that LSB image steganography. So whatever secret data we got, we will hide them in the LSB of the data present inside the image. So what we are doing is that here we are doing LSB steganography, in which we will modify the LSB bit of the data present inside the image, and we will encode the secret image, and we will decode accordingly. So about images, so image is a file which contains pixels. It is known as pixel elements. So pixel is the smallest value. It is the smallest element holding the value representing the brightness of the given color in the picture. Pixel is the smallest addressable and controllable part in the picture. So as in the image suggests, if we look into this image, if we are zooming this part, we will get grids, and that grid represents the pixels. So here it is an RGB picture, so it consists of 3 bytes, and each have its own binary value or hex value, in which in our project we are actually modifying the LSB, and we are passing the message, and we are encoding it in the LSB of the image. So pixel is the smallest addressable and controllable part in the picture, and we are utilizing these pixels to encode the data into the image. So coming to the format, every image has its own format. File formats are standard mean of organizing and storing digital information. And the digital data can be rasterized. And once rasterized, an image becomes grids of pixels, and each of which has a number of bits to designate its color equivalent to the color depth to the display to the device displaying it. So after rasterizing, the image actually will become grids of pixels, and each pixel has its own value. The depth for each pixel, the color, so it will vary according to that color depth. The device will display it accordingly. So for each and every pixel, there will be RGB values which will determine the coloration contrast. Coming to the pictures itself, there are different type of pictures. There is grayscale picture, black and white picture, RGB picture, magenta, cyan, yellow, and black picture. So for each type of images, the pixel size varies. So for grayscale, it's only just there is only one color, so it's 1 byte. For black and white, it's a combination of black and white, so it's 2 byte. For RGB, it's 3 byte. For magenta, it is 4 byte. For the resolution part, as the number of pixels increases, thus the depth of colors and all increases, so the resolution also increases. Coming to the BMP part, BMP format. Here in this project, we are using a .bmp format. So BMP stands for Windows Bitmap. It handles graphic files within the Microsoft Windows OS. It is an uncompressed, and therefore it's large and it is lossless. Their advantages is simple structure and wide acceptance in Windows programs. So we are using the BMP format, and it has its own advantages. It is uncompressed and it is large and there is no loss, and it is in simple structure. That's the reason we are using BMP format. And the first 54 bytes of the BMP file will be its header file, and in the 18th and 19th bit, it denotes the height and bits of the image. Before encoding the message, a message to the image file, we actually want to know whether the image is capable of holding the data, whether it has that sufficient number of data to encode all the messages into the file. So in order to get that file, we need to in order to get that size, we need to get the height and width of the image. So in the header file, in the 18th and 19th offsets, the height and width of the image is denoted. So, and since the image we are using is an RGB file, so it's a 3 byte pixel. So the size of RGB data in pixels will be width into height into 3. So in total, this will be the total size of our image in which we can utilize the data for encoding. So coming to the project LSB steganography. In this project, we are encoding a message in such a way that the quality of the image doesn't change that much. And the LSB of RGB data is modified to encode, and by collecting the LSB of the encoded file, decoding is done. So basically, we will take an image file, we will take the RGB data. For each bit to be encoded, we take each byte of data, and for each byte of data, we modify the LSB with. And let us say to encode a character, one character, it's of 8 bit, that is a single byte. For a single byte character, we need 8 bytes of data, and 8 bytes of data LSBs will be modified. And while decoding, we will collect these LSB data, 8 bytes of, from these 8 bytes we will collect 8 bits of LSBs, and we will join it together in a way in which we encoded, similar to the way, or opposite to the way like we encoded, and we will form that character data while decoding. So a secret file is encoded into an image file and create an encoded image stego.bmp. So in this project, we are sending the file, image file and secret file along with the command line arguments, and we are providing an option whether to encode or decode. Like -e denotes the encoding and -d denotes decoding. So we are passing this arguments as input to the program, and while encoding, a stego.bmp file will be created. So after encoding, stego.bmp will be created as part of our encoding process. And while decoding, we will get the secret message. Like whatever we have encoded, that file will be we will receive after decoding. The files are checked whether a BMP file is passed, whether it is a .txt file and all. It will read and validate the arguments. Whatever the command line arguments that has been passed as input to the program, that will be read and validated. Whether that file exists and everything will be checked, and afterwards the encoding part or decoding part will be done. As per the input options like -d or -e, whether it is encoding or decoding, that particular operation will be done. So this is the overall project overview. There is a secret data and there is an innocent image, and we will encode, we will pass the innocent image and secret data as command line arguments with the -e option, and we will produce stego image. So this is the encoded image. Stego image is the encoded image, and while decoding, we will pass the stego image, and after decoding, we will get the secret data. So that's the overall overview of the project. Coming to encoding. So what is encoding? Encoding is a technique where the data is transformed from one form to another. And encryption is a technique used to protect the confidentiality of the data. So here we are encrypting actually. So we are encoding that character files into image file. We are converting character into image data, and we are taking BMP file, and we are using BMP file, and we have already explained what are the advantages of BMP file. It is an uncompressed and large file. It will have sufficient data, pixel data, for us to do the encoding, and it's easier. Taking data from .bmp file is easier when compared to other image files. So that's the reason we are using .bmp file. And secret file is encoded to BMP file by modifying the LSB RGB data. So as you see, this is the RGB data, and this is the binary form, and this is a secret message. Let S ASCII code of S is 73, and we are actually adding these bytes one by one to the LSB of each pixel data. So after encoding, a stego image is formed. In this project, these much operations are done. So first of all, when we are passing the command line arguments, or whenever we are trying to run the code, we will check whether valid arguments are given. Like if in this example we have not passed any file, so actually that will throw an error message. And also the files, whether the file is valid or not, whether the files and these .bmp and .txt files, that will be done in the read and validate arguments part. And then afterwards the files will be opened, and before encoding, we want to actually get the capacity. We want to get the capacity of the image, and as well as the secret file size. To get the image size, we will actually check the 18th and 19th of bits of the BMP header, and from that, as per the previous equation, width into height into 3, we will get the size of the image. By using file operations, we will travel from the starting of the secret file to the end of the secret file, and accordingly we will get the size of the secret file. Then we will get the capacity. We will get the capacity of both files. And before encoding, actually we want to encode a magic string. So a magic string is a string that is kind of a key to open a lock. Like let us say if we want to decode an image, we want to know whether it is encoded or not. So beforehand, if there exists a magic string, we can confirm that it is encoded. For encoding operations, we are actually using that magic string, and it is of two characters, hash and star. So it's of 2 bytes. So in total, it is of 16 bits. For magic string, it needs 16 bit. For encoding secret file extension, let us say we are using .txt file, needs 4 bytes of data. .txt 4 bytes, that is 32 bits of data for .txt. And for secret file extension, that's also 4 bytes, so 32 bits for that. And secret file size, for size is in integer, so that also we need 32 bits. Then for the secret file data, let us say there is 100 or 200 bytes of data. So for that size also and for the data also, we need that much accordingly. So all of these data will be taken into consideration, and we will check whether the capacity is capable, whether the image is capable of encoding all these data into its image accordingly. If it is capable, then we will start the encoding process. So first of all, we will copy the BMP header. Originally, we are using beautiful.bmp, and it has 54 bytes of header data, which we need to be retained for the Stego image. So Stego image will also have the same header. We will copy the 54 bytes of data. First 54 bytes of data, since it is a header file, it will be copied directly. Then after that 54 byte, we will utilize the image data, that is the RGB data or pixel data. We will utilize that for encoding purpose. If we want to encode one character, that is 8-bit data, we need 8 bytes of image data. After getting the BMP header and copying the BMP header to the Stego file, we will encode the magic string, that is of 16 bits. We will encode the magic string, and after encoding the magic string, we will encode the secret file extension size. After the extension size, we will encode the secret file extension. Then we will encode the secret file size, and after that we will encode the secret file data. And even after doing all this, if there exists a remaining data from the image, all the remaining image data will be copied to the Stego image data. For doing this purpose, we are using file operations. Image beautiful.bmp is opened in read-only mode, and the Stego image is opened in read mode. And whatever the values or to be encoded that we are reading from the image data, we are doing the bit manipulations, and we are writing it to the Stego.bmp. So that's the encoding part. So this is a brief explanation of how we are encoding the bits. So for magic string, hash and star is a magic string. So hash value is 0x23, and the binary value of 23 is 00100011. That is this. And we are taking the first 8 bytes of image data, and we are encoding bits into the LSB, that is the least significant bits, that is the rightmost bits. We are encoding this character data to the image data. So we can see that here it was 1, it is encoded with the 0, and the image data or the LSB is changed. For doing that purpose, first of all we will clear the LSB data, and then we will OR with bits to the LSB side. So the resultant byte will look like this. So coming to the decoding part. So decoding is a technique where the encoded message is decrypted. Like whatever the changes we have done in that LSB, that LSB bits we are collecting, and we are forming a character so that we can retrieve the message successfully. So decrypting, on the other hand, is for converting a signal to its original data. Whatever actually we have done, that we have changed the character to image data. Now we are actually changing that image data to the original character data. After decoding, the secret file or message can be retrieved. Modified LSB bits from the RGB data is taken, and encrypted data is restored, and it is written to the designated file. So we are opening another file, a text file, and we are opening it in write mode. Or we are actually collecting the we will collect the bits, and we will form the character using bit manipulations, and we will write each character accordingly into the file. So this is the 8 byte modified data. We will collect these individual LSBs, and we will form together to form together to get the resultant data, and we will get the resultant character. That's done in decoding. So in decoding, these much operations are done, and the first operation is we will read and validate the arguments, whether sufficient arguments is passed or not, and whether the MP file is passed or not. That we will check, and after that we will open the files. We will open the stego.bmp in read mode, and we will open a file. Can be the by default we will create a file. If we want to give a name to that file, that also we can pass along as a command line argument after stego.bmp. After this part we can send a file, so that file will be open in write mode. First we will check whether there exists a magic string. If there exists a magic string, then then the file what we have sent is encoded actually. So first we will check for the magic strings. After the 54th byte we will collect the consecutive 16 bytes, and we will decode and check whether there exists a magic string. If there exists a magic string, that hash and star characters are present in order, then we can say the file is encoded. So if that is successful, then we will decode the secret file extension size, and we will decode the secret file extension itself. Then we will decode the secret file size. Then we will decode the secret file data. So if decoding is done properly, we will get a successful message like this. After decoding, that secret file will be available in the form of .txt file, and we can check what is the message that we have sent. This is the main function which does the encoding. So we are taking 8 bytes of image data, and we are doing the bitwise manipulation. We are taking the image data in char image buffer, and the last bit or that index bit is cleared. LSB byte is cleared. The character data is overed with the image data, and that is saved accordingly. So this loop runs for 8 times, and for integer values like for 32-bit, the operation is same, and this is function for decoding. This is the demonstration of a project. So as you can see, there is a beautiful.bmp file. There is a secret.txt file. That is a file contains a secret message which has to be encoded into the image. And this is the main file, test encode.c. Then encoding file is encode.c, and the decode file is decode.c. So we can open the terminal. So let's test the validation, like whether that command line arguments is passed or not. So we are not passing any files as command line arguments. So this is a way in which how the file command line argument should be passed. So for encoding, it should be given as dot slash dot out hyphen a beautiful.bmp, second dot txt, and stego.bmp. Stego.bmp is optional. We can give it if we don't want to give it. So okay, that's also fine. So first of all, let's do the encoding. So before encoding, we can check whether that stego file is created or not. So here, as you see, there is only a .out file, and there is no stego image file, and this is the beautiful image. So we will encode. So the encoding is done. All the details have been displayed here, and it is done successfully. So let's again go check whether it's there. So the BMP file is created, and there isn't any difference between the beautiful.bmp and stego.bmp. It's exactly look alike. And let's decode the image. So we are decoding that stego image, and we are storing that decoded messages into decode.txt. So before going into that, let's check the message that we have encoded. So my password is secret. Go to C project is the file that we have encoded. So decoding is done successfully. Everything is done accordingly. Let's check for the decoded file. So here comes the decode.txt, and both are same. secret.txt and decode.txt has the same message. So decoding is done successfully. So that's it. That's all about that LSB steganography project. Thank you.